All right, so we're going to now go into quadratic equations. Remember, quadratic is a U-curve, and we call that a parabola. We have two formulas that we worked with consistently. One is standard form, which is y equals ax squared plus bx plus c. And then the other is the vertex form, which is y equals a. And then in parentheses, x minus h raised to the power of 2. My 2 did not make it there. My 2 right here, plus k. All right, so we're going to get started by looking at some graphs. How can I get this equation onto a graph? And the first thing I notice is it's in standard form, so that's great. So we really need a vertex, right? We need a place to start. So let's go ahead and use our axis of symmetry. Remember, axis of symmetry, our AOS, equals negative b over 2a. So we're going to start there. So x equals negative b, so a negative 6 that's negative would be a positive 6 over 2 times 1, which is 2. So my x is 3. So I already know right off the bat my axis of symmetry, 1, 2, 3, is somewhere down this line. Okay. Now if we know x, we can always go find y, so let's plug that in. Y equals 3 squared minus 6 times 3 plus 8. So y is going to equal, well, that would be 9 minus 18 plus 8. If I put that together, this would be negative 10 and 9, so my y equals negative 1. So my vertex is 3, negative 1. Okay, 3, negative 1 right here is my vertex. Go ahead and label that over here. That would be 3, negative 1. Axis of symmetry was x equals 0. Now, y-intercepts. Remember, my y-intercepts is where y equals 0. And in a standard form, it's just going to be where the constant is. So when x is 0, y would be 8. So I already know that. So let's go up to 8. 1, 2, 3, 4, 5, 6, 7, 8. There's my y, which tells me that using symmetry, if it's 3 this direction to axis, then my other 3 would be here. And I can draw a pretty good parabola coming up from here to here. Kind of have an idea just by looking at this what my parabola would look like. I know my domain here would be all real numbers. And my range would be y is greater than or equal to, well, negative 1, right? Because I know that that's the minimum. It's opening up. So what I really just need to know is what my solutions are, my zeros. Now I'm going to do that on this problem simply using factoring, because what two numbers multiply to 4 or to 8 to get to negative 6? Well, negative 4 and negative 2, right? So let's just go ahead and break that down. So remember, if I set it equal to 0, I would be able to say that that is x minus 4 and x minus 2. We would tee those both up and set them equal to 0. So I'd have to move the 4 over and the 2 over. And I'd say, well, then my zeros are at 2 and 4. And that's pretty close to my drawing. So yeah, that makes sense. Okay. Number 26. Much of the same, I have a standard form. So if I'm in standard form, I'm going to go find my axis of symmetry first. So I'm going to say I want my AOS. So I'm going to put that in, negative 4, negative b over 2 times a, which is 2 times negative 1. That would be negative 4 over negative 2, which would result in a 2. So I know that x is 2. That is my axis of symmetry. I know that that means that it's going to be somewhere down this line. Remember, that dotted line means my axis of symmetry. Then I'm going to plug that back in. I need to find y. So y equals negative 2 squared. Don't forget that this is taking a negative times the 2 squared. Not negative 2 squared, but negative times 2 squared. Oh, I should have put the 4 times 2, not x. So let's do that. Times 2 minus 5. So this would be negative 2 squared is 4 plus 8 minus 5, We put all this together, that would be -9 and 8, which would make -1. So my vertex is at 2, -1. So 2, -1. Okay. And, well, I know when I look at this problem, see the negative in front of the A? I know that it opens down. And I probably could figure that out using the y-intercept. So let's go look at the y-intercept. Remember, I'd put 0 and 0 in, which would just leave me with the -5. So 0 and -5 is my y-intercept. 1, 2, 3, 4, 5. I'm going to use symmetry to create another coordinate. I kind of know it looks like this in a roundabout way. It's a nice sketch. So we need to fill some things in. My domain, all real numbers. My range, y is less than or equal to my maximum, which is -1. And my zeros, or where it meets it, is when it's a null set. Remember, you can put like empty braces for a set, but there's nothing happening here. It never goes across the x-intercept. So let's go ahead. I'm going to flip over and look at another one. All right, number 27 here. Same thing. Here though, I do notice I don't have the x term, right? I have an x squared and a constant, but it's still in standard. It says y equals. So I'm going to go ahead and go find my AOS, but I do know that means I have no b, so the b is 0 over 2 times 3, which is 6, which means my axis of symmetry is at 0. If I know my axis of symmetry is at 0, I can find my vertex here by putting in the -3 with that 0. So again, my y is just going to equal -3. I just plug that back in. So my vertex is at 0, -3, which is also my y-intercept, right? Okay. I know it's opening up because it's positive, and I know what my range is. I know that it's going to be y is greater than or equal to -3. I know that my domain is all real numbers, but I really kind of like to know what my solutions are so that I can get a decent looking graph here. So let's go ahead and factor this out. This would be 0 equals 3, and then if I factored out a 3, it'd be x squared minus 1. Difference of squares, so x minus 1 and x plus 1. Remember, we would t all of this up to equal 0. 3 does not equal 0. And x minus 1 equals 0 will simplify or solve to make x equals 1. X plus 1 will solve to make x equals -1. So my intercepts would actually be at -1 and 1. This is going to be a pretty skinny parabola. Looks something like this. Again, just a sketch to make sure we're going in the right direction. Now, 28's a little different because 28 we are no longer looking at, our standard form. We are in vertex form, which means we know that the x-axis of symmetry, or the x value, is, remember this is like, I'm going to put this in here, minus h, so my h is actually -4, so x equals -4. The vertex is given to me, so it's going to be -4, 9, because the k right here at the end is that, tells me that. Now, domain, I kind of already know the domain. It should be all real numbers. And when it comes to range, well, I know what the vertex is. I need to figure out, is it opening up or down? So it's opening down. I know that because the A is negative. So if it's opening down, this is the max. So I can say, well, then y is less than or equal to 9. But what I'm really kind of looking for are my zeros here, right? I need to figure out what my y-intercept is, and I need to figure out what my zeros are. So if I want to know what my y-intercept is, I'm just going to put 0 in for x. So that would be y equals -0 plus 4 squared plus 9. Order of operations, so -4 plus 0 is 4. I need to take this square, so I want y equals, I want the negative of, remember that, so negative, that's 16 plus 9, so my y equals negative 7. So when I put 0 in, my y-intercept is at negative 7. So that kind of helps a little bit, kind of gives me a little bit of a graph. So negative 7 is way down here though. 0, 1, 2, 3, 4, 5, 6, 7 is way down here. Now let's go back and put in our vertex. We said negative 4, 9. 1, 2, 4. 9 is way up here. So we're 4 away. So that means if this is my axis of symmetry, it's 4 this way. It's also 4 this way. 1, 2, 3, 4. So this is sort of my rough parabola. But I need to know what are my zeros. And really what we want to do here is we would have to go back and expand this out so that we can figure out the math here being y equals, I want the negative of x plus 4 times x plus 4 plus 9. So we're actually going to distribute. So I want the negative of, this would be x squared plus 8x plus 16 plus 9. The negative comes through, and then we would have negative x squared minus 8x minus 16 plus 9. And we could go again, which would give us negative x squared minus 8x minus 7. Okay, now I don't want a negative out front, so I'm going to multiply the whole thing by a negative, which would leave me with x squared plus 8x plus 7. And you can factor that. What two numbers multiply to 7 and add to 8? Absolutely, 7 and 1. So I'm going to go ahead and bring this up here. That means I have x plus 7 and I have x plus 1. I'm going to tee that up because I'm going to factor it up to here. So this would then be x equals negative 7 and x equals negative 1. So those are my x-intercepts. Now let's go see if that makes sense on my graph. Could that work out? Let's see, 1, 2. So there's negative 1 here. 2, 3, 4, 5, 6, 7. And that absolutely does look like a pretty good parabola from there. So let's go ahead and draw that. So when we're looking to find zeros, what we need to do, even when we're given it into vertex form, we're going to go ahead and turn it back into standard form, because from standard form we can factor or use one of our other formulas we'll talk about here in a little bit again. So number 29, again, this is vertex form, and it kind of gives it away because the parentheses are kind of holding together the x with the -1 and then squared. So I know my axis of symmetry here is x equals 1, just straight from the formula. I know my vertex is 1, 0, just because there's not a k. Remember, I just say, well, that's kind of like plus 0 here. So my vertex is at 1, 0. I know it's opening up. I can find my y-intercept by plugging 0 in. So y equals 2 times 0 minus 1 squared. So that would be 2 times negative 1 squared. Now we got to do the exponent first. So 2 times, that would be negative 1 times negative 1, which is 1. So when I put 0 in, I get 2. So my y-intercept is 0, 2. My domain, of course, all real numbers. And I need to find my range. So I need to know, is 1, 0 the top or the bottom? If it's positive, it's going up. So that would be my minimum. So it'd be y is greater than or equal to 0. So really all I need now are my x-intercepts. And I want you to stop and think, you know your x-intercepts. Here, I'm going to go ahead and plot these real quick so I can draw this. It's a really small parabola. And we know our x-intercepts because when we graphed it, our vertex landed on it. So since our vertex landed on it, our x-intercept, or our 0, is simply 1. We didn't have to multiply that out because we only have one solution here. So that's just kind of a quick review of how to find the axis of symmetry, the vertex, domain range, just using a graph and plugging in enough information to be able to sketch that.